In this video, you'll build a yield farming strategy that uses wBTC, it invests it in AAVE to earn interest, as well as staked AAVE, and it will then Uniswap to swap the staked AAVE and turn it into wBTC. The strategy should earn around 1.2% APY, and in this video, you're going to be setting up the development environment, then you're going to be writing the strategy, and then you'll also write tests for it. We're going to be using the Badger strategy mix, which simplifies the amount of work you have to do. And with this simple starter kit, you'll be able to write, test, and deploy your strategy by changing just 3 files. Before we jump into coding, I want to show you how you would even find this opportunity. And the reality of it is that you will go about your day-to-day life, perhaps on Twitter or something like that. And then you will stumble on the, in this case, on the AAVE platform, and you will see that they have liquidity incentives. So if you go on mainnet here on the market V2, you'll see that you see this number up here, which is the APY for depositing, and then you also have the incentivized APY, which means that if you look here at wBTC, you'll see that you basically get nothing by depositing, but you do get a really juicy APY here from staked AAVE, and that's how you will go about finding it. Perhaps you would even try it, by putting, 100 Satoshi or something like that on AAVE so that you get a feel for it. And after you do that, you would be able to then get started with coding, which is what we're going to be doing next. Let's get coding. The first thing you will do is you will find the source code, which of course is going to be in the description, but you can also Google it by Googling GitHub Badger DAO. And then you will find Badger Finance, the project. And then you can scroll until you find the Badger Strategy Mix V1. This is the repository you're going to be using, and I'm going to talk about it and you're going to be using it throughout this video. But there's also a full detailed introduction if you want to go even deeper. That said, you will get started by clicking on Use This Template, and then you can fill in a name. In this case, I'll call it wBTC AAVE video, and then I will create the repository from the template. Once the template is done, you can click in the green button here and you're going to get an SSH link. We're going to copy that so that we can clone our repository locally. I'm going to open the terminal. And here in the terminal, I'm gonna clone the repository by typing git clone and then pasting the name of the URL that we just copied. We can then cd into the folder. In my case, it's called wBTC AAVE video. So I'm gonna type cd wBTC AAVE video. And at this point, we need to install a bunch of dependencies. You can try and see if you have Ganache and Brownie by typing Brownie. And if you do get a response, that means that you do. You can also try typing Ganache to see if you do have access to Ganache, specifically Ganache-CLI. And you should see some sort of result. If you do not, then you're gonna have to also Google how to install Brownie and Ganache. And trust me, that's probably a good idea. And I'll just show you a very quick reference. You can just go Brownie docs and you can find the documentation for if Brownie. So you probably will be better off starting up here and just going through the installation process to make sure you have all the dependencies for Brownie. That said, for our monorepo, we need to install the JavaScript dependencies, and we can do that by typing npm I. And then you can install the Python dependencies by using pip. In my case, I don't have pip, I have pip3. So that's the one I'm going to be using. I'm going to be using pip3, and I'll type install virtual env. And that's because I need to install this virtual environment manager. And then I'm going to run it by typing virtual env VNV, so virtual env VNV, which creates a new virtual environment. Then I'm going to activate it by typing source vnv/bin/activate. There we go. And you can see here on the left that we have the VMV. If you paid attention, I actually already had it, but that's okay. And then I'm going to install the dependencies, which is the most important thing, by typing pip free install -r requirements.txt, which is going to install all of the Python Brownie dependencies. There we go. The last thing we need to install is a couple of API keys. So let's open our code with Visual Studio Code. I'm going to open it up with Control O. I'm going to go in Study, wBTC AAVE video. So now I have the project open. And here on the left, you'll see a file called .env.example. I want you to copy paste it and then rename it to .env. And now you're going to need to populate these two parameters, which are the Etherscan token, as well as the Web3 Infura project ID. The Etherscan token can be found on Etherscan. You're going to have to sign up and then go for API keys, and then you want to paste that in, while the Infura token can be obtained by going on Infura, signing up, and then getting the project ID. Once you do that, we're finally ready to go and code. At this point, we are set up and we can start coding. Before we do so, I'm going to give you a very brief introduction. Here you can see that there's many folders, but fundamentally, in order to code this project, you're going to need to only customize 3 files. One of them is in contracts and it's called My Strategy. This is going to be the solidity code of the smart contract that is going to enact our strategy. So obviously that's the one we're going to spend the most time on. Then you're going to need to change a couple of files up here in the config folder. One of them is called init, and as you can see, it contains a bunch of variables. You will simply have to customize the want, the LP component, and the reward token based on the tokens that we're going to be using in our strategy. And then lastly, you're going to need to edit the StrategyResolver, which is a tool that allows us to run tests against the state of our smart contract before a transaction and after a transaction, which basically means that all of our tests can be automated as long as you can just customize this very small set of code. So I'm going to just jump right into the smart contract development, and then we'll be building tests as we continue. All right, let's get coding. We're going to open up the contracts folder. The file is called My Strategy, and we're going to be focusing on this for quite some time. So the first thing we want to check is that we're going to have 3 variables, and we can see them up here, but we can also see them being set up on line 40, 41, and 42. We see that the want config is being set so that we have a token, an address called want, an address called LP component, and one called reward. The want in our case is going to be wBTC. The LP component is going to be a wBTC, the BTC once we deposit on AAVE, and then the reward will be the stake AAVE token. That means that we need to set those up. So as you'll see, the way these are set up is actually in the script deploy, and the configuration, which you can briefly check here on line 61 of the script deploy, will basically set up all of the tokens here on line 67 for us. That means that the only file that you actually have to change is here in the config folder, and it's the init file. So we need to change the want to wBTC, the LP component to AAVE, and the reward component to STK-AAVE. So we're going to go on Etherscan and we're going to find them out. Let's open up Etherscan. We're going to search for wBTC and wait for the autocomplete, then click the first result. It should begin with OX22. Let's copy that address, and you can do that by double clicking and copying, and then let's paste it in the want. So now we have set up wBTC. Let's search for AWBTC here, AWBTC. Notice that there's 2 results. That's because the first one is the V1 of AAVE. We actually want the V2, so instead of the FC version, you want the 9F. So click on the AAVE wBTC that begins with 9F. Make sure it's the second version, you can see it here on the left, and then copy the address. Then paste it in the LP component. Lastly, we need to set up the reward token. So let's go in the Explorer, type STK-AAVE. Notice STK-AAVE, And this is the staked AAVE that we need. Let's get that address and then paste it in the reward token. We already set up our configuration. That means that all of our automated deployments and testing are already set up to use the tokens that we set up. That's pretty amazing. So just to give you an insight as to how awesome and how much progress you already made, I'm actually going to show you that just by changing these variables, you basically redefine the entire behavior of the system. So I'm going to go in the terminal, and we can actually run the Brownie console by typing Brownie console, which puts us in an interactive environment that is going to compile our contracts and basically allow us to use them on a forked mainnet. And if this loads too slowly for you, it's probably because you didn't set up the Ganache, or sorry, the Etherscan or the Infura keys. So make sure that you set up that .env file, because typically that's what happens. After a while, you should see Brown environment is ready, which means we're ready to do a little bit of interactive coding. And what we're going to do is we're going to deploy our contracts and store them in a variable. And we can do that by typing deployed equals to run of open parentheses, open double quotes, deploy, which means that this variable will receive the value of running a script called deploy, which I briefly showed you. If you want to investigate the deploy script, you can go in the scripts deploy.py and you can read it over. But fundamentally, what it does is it sets all of our infrastructure, which is called controller and set, which is a vault. And then it sets up the strategy, which is the code you'll be writing. And not only does that, but it also swaps a little bit of Ether, 5 Ether, to wBTC, so that you have some of it to play around with. Let's go back in the terminal. We see that we have that. We can verify what happened basically by typing deployed. And you'll see that now you have that the deployed variable is set to this object, this .map, that allows you to interact with a bunch of contracts. We could, for example, check the balance that we have by typing deployed.balance, or excuse me, deployed.want.balance of address 0, which we can do by typing a square bracket 0. And we use address 0 because by convention we set that as the deployer. And we can see that we actually have this amount of Satoshi. We already have a bunch of Bitcoin. We could actually continue interacting with the console. However, if you're interested in seeing that, the video that does a demo of the monorepo, which is going to be in the description as well, already covers that. So for the sake of brevity, we'll actually just continue with writing our strategy next. Let's continue with coding our application. We can exit the console by typing quit as a function, and then we'll switch over to Visual Studio Code. I'm going to close everything except the mystrategy.sol file, which is in the contracts folder. At this point, what we need to do is we need to start writing our strategy. And our strategy, as we already discussed, will have a function called initialize, which allows us to set up one-off configuration and approvals. Then we have a bunch of view functions for getting the name, the version. Then we have a function called balance of pool that needs to determine the amount of tokens that we deposited and that we're currently investing. And in our case, that will be the amount of tokens in the AAVE pool. So basically the balance of the pool for this contract. Then there's a view function called isTendable, which we want to set to true if the strategy should be tended by the by a bot or by a keeper. Then we have the get protected tokens, which basically enumerates the tokens that cannot be moved unless there's a very real reason, and that will only be done by governance. So basically these are tokens that you don't want to be able to rug. They have to be protected. Then we have this keep reward, which we typically will not customize. We have a modifier here called only not protected tokens that is used to check again against the get protected tokens to avoid moving tokens that we're not supposed to. And then we get to the meat of the strategy. We have the deposit that, given a certain amount of want tokens, needs to invest them. So that's what we're going to do. We're going to deposit in the AAVE strategy. Then we have the withdraw all, which is used to withdraw all of the tokens off of the investment, basically off of the lending pool. Then we have the withdraw sum, which is used by other accounts to withdraw their investment. And as such, it's going to be used to just liquidate to the amount of tokens that need to be withdrawn. Then we have harvest that is used to reap the rewards, Uniswap them, and basically buy more wBTC so that we can earn them. And you can see this function here, process performance fees, which actually is used to pay out strategists. So if you actually end up submitting a valid strategy to BadgerDAO, we have a big bounty on Gitcoin that pays up to $5,000 for any valid submission. You will also be entitled to the strategy's performance fee, which is actually 50% of all the performance fees. So make sure to keep this function here if you're interested in continuing. Then we have a tend function, which is used to rebalance the portfolio. You can see that we also have this harvest function with a price, and this could be used to avoid being front run. For the case of our tutorial, we'll actually skip it, but this is actually a great idea because that way you can't get sandwiched. And obviously an even better idea would be to use some sort of external oracle such as Chainlink or a TWAP oracle. So at this point, we know how the strategy looks. We actually need to code it. And the first thing we need to do to code it is we need to learn about how AAVE works. And I have the docs here. If you are in the developer docs, you would just search for V2 contracts and then search for the lending pool. And we need to use the lending pool so that we can make a deposit. What we will do is we will first of all need to get the source code for the lending pool interface. And we can find that by exploring the AAVE code. So we'll go in contracts, interfaces, and search for lending pool. You can see here lending pool.sol, and we can basically yoink the file. We can copy it and paste it. So we'll see that this uses a version of Solidity called 0.6.12. We actually use a different one, so we'll have to change this. But fundamentally, we just need to port this over to our project. And what we're going to do to do that is we can go in Visual Studio Code. We're going to open the File Explorer. And here, we'll go in the Interfaces folder. We're going to create a new folder called AAVE. And then create a new file called I in uppercase, L in uppercase, lending pool.sol, which is the interface for the lending pool from AAVE. Let's then go back on Google Chrome and click on row, and then copy the entirety of the document by using Command A, Command C, and then Command V. Something you'll notice is that there are more dependencies up here, so we actually need to import more stuff. For now, we're gonna change this Pragma Solidity to the one that we have in my strategy, which is up to 6.11. So let's just change it to that, 6.11. There we go. And now we also need to port over the same two files, one called the lending pool address provider and another called the data types. So let's go back in Google Chrome and navigate back and search for the lending pool address provider. You can copy the name and then search for it. There we go. So let's open that up. You can see it has no dependencies, so we're gonna have to do less work for this one. We're gonna go in Visual Studio, in AAVE, new file, lending pool address provider.sol, and then go in GitHub, click on row, and copy the code, and paste it, and then change the Solidity version to 6.11. And then we need to do the same for the last file, which we can get from lending pool. And the last file is called data types, and it's in a different folder. So I'll show you a secret to find stuff fast on GitHub. You're gonna copy the name data types, and then you're gonna go in the Explorer, click on Go to File, and then paste this name, and you'll immediately find the file you're looking for. At this point, let's copy the name up here, and then create a new file in AAVE called datatypes.sol, and then row and copy it fully. We're gonna change this to, again, 6.11, and then the last thing we need to do is change the paths in lending pool. We're seeing that we're importing from protocol. We'll actually just import from / so that we're importing from the same folder. At this point, we have the interface that we need. The last part of a contract, the other part of a contract, is the address. So let's search for the lending pool address. We're gonna go in Google Chrome, go in the lending pool documentation, and we can actually search for deployed contracts main market, and you find lending pool here. Let's see this address. This is the address we're interested in, and we're gonna copy it from up here on Etherscan. So we need to set that up. We're gonna set it up down here after line 26. We'll type address public constant, and since it's a constant, I like to call them with all caps, so we'll call it all caps lending pool, equals to this address. So that's set up. Let's import the interface for AAVE here on line 14. Import double quotes / slash interfaces slash AAVE slash I landing pool. Make sure to type it exactly as the name of the file. And advice I can give you will be to rename, Command A, Command C, and then paste it so that you can't make a typo if you copy paste the same name of the file. That means that now we have access to the iLending pool interface, and that means that we can actually perform the deposit, the withdrawal, etc. We're gonna now fully focus on the code, and at this point we can actually set it up so that it will work. The first thing we need to do is use this lending pool address so that we can approve it. So let's go down here, line 52, and comment this example, change, actually keep want, and then change safe approve. This is the parameter that we are approving. Let's approve lending pool, which means that now lending pool can take our deposits so that because we approved it on the initialization script. At this point, let's change the name of the strategy to wBTC AAVE rewards. I'm gonna do it dash separated, but you can also do spaces, that's fine. Version is gonna be 1. The balance of pool, in our case, is gonna be the amount of A tokens that we have. And in our case, A tokens are called LP component, but since we're dealing with AAVE, because normally we will always call it LP component because it's a generic name, but since we're working with AAVE, we're actually gonna do a global renaming. So do Command F, then open the dropdown and change it to A token everywhere, and click this second option to do a global replace, because it's just, that's what it is. It's an A token. We call it LP component when it's something more exotic, but A token makes sense in the context of using AAVE, so let's do that. So now here on the balance of pool, we're just gonna get the balance that we have of A token. So let's type I ERC20 upgradable of A token dot balance of, and we're gonna type this address, which means address of this. It means the address of this contract. That's the amount of tokens in the pool. This strategy will be tenable, so let's return true. And next, we're gonna scroll down. We don't need to change the protected token. We don't need to change the keep reward. This one is a modifier, let's not change it. And then we're gonna use the deposit function. In deposit, what we're gonna do is we're gonna get the interface for lending pool with I lending pool, open parentheses, the address lending pool, which means that we are casting the address to this interface. And then we're gonna call dot deposit on it. And you can see that if you press enter, you get the autocomplete. The asset is going to be want. The amount is gonna be underscore amount, which is the amount we receive in the function signature. The on behalf of will be address of this because we are depositing for this contract. And then the referral code will be 0 because we don't have one. Next up, we have the withdraw all. And to withdraw all, we just need to withdraw all of the balance from the pool. So we can simply perform that by running iLending pool of lending pool dot withdraw, and we're gonna set the asset to be want and the amount to be balance of pool. Basically the function we already defined up here, balance of pool. And lastly, the to is going to be changed to address this because the contract wants to withdraw for itself. Next up, we have the withdraw sum, and for some reason you can actually end up trying to withdraw more than what you have. So to avoid that, we're gonna cap it, and we can do that by typing if underscore amount greater than balance of pool as a function. Then we're gonna set amount to be equal to balance of pool, which ensures that we never go over the limit. And lastly, we're gonna actually perform the withdrawal here in line 122. Let's type iLending pool of lending underscore pool dot withdraw. The asset is gonna be want, the amount is gonna be underscore amount, and to is gonna be address of this. There we go. Now we see the harvest function, and the harvest function is gonna be the toughest one. So we'll actually skip it for now. We're gonna actually finalize everything else, run some tests, and then we're gonna deal with harvest. so that you get the gist, and then we'll actually finalize the harvest. So the last function we want to check is tend, and tend can be used to rebalance the pool. In our case, we just want to make sure that all of the want is deposited. So what we can do is we can check if balance of pool is, if balance of want is greater than 0, then what we're going to do is we're going to call iLendingPool on the lending underscore pool, and we're going to run deposit with the asset being want. The amount is going to be balance of want, and on behalf of will be address this, and the referral code will be 0. There we go. Basically, if there's a balance, let's deposit that balance. And you may be asking yourself, where did we get this balance of want function? Let's search for it. You'll see that it's used only here. And that's because we are setting up this my strategy, which actually is a base strategy. So if you go in the definition for base strategy, which is a file that we have under the deposits or the dependencies folder, the deps folder, you'll see that we do have a lot of nice to haves. And basically we're abstracting away a ton of stuff so you don't have to deal with that, because these are all very generic methods that are always the same. So you may want to dig that deeper if you're curious, but that said, you can actually write your own strategy without even knowing that. So at this point, we wrote all of these initial tests that have to do with the lending pool. So this would be a great time to try and compile it, trying to deploy it locally, and then run a couple tests. So let's do that. It's always a great idea to compile the contract as soon as possible to see if there's any mistakes. I'm pretty sure we will get a couple of errors, and so that's a great learning opportunity. So let's try that out. We're gonna go in the terminal, and we're gonna type brownie compile to run the compilation of our contracts. We expect a couple of issues. In this case, I actually made a typo on lending pool. You can see here that we get these dashes and these arrows telling me what the mistake was. So I'm gonna search for lending pool and change it to lending pool. So that's great. Let's try again. I do believe we will get an address issue, and I'll show you how to fix it. I guess we didn't. If you do get an exception related to the address not being checksummed, which I've seen it happens when you copy addresses from Etherscan, then just make sure to get the checksummed address from the Brownie console, and you're going to be able to fix that as well. Our compilation was successful. Let's just run a, I guess we can run a few tests by typing brownie test. And the test will actually fail. There's many reasons why they will fail, but fundamentally the biggest reason is that we never edited the core resolvers. So that's something that we want to do in order to ensure that the ordinary operations of our contract are done properly. So while some of our tests will pass and the majority of them will fail, let's actually go ahead and edit the resolvers next. In order for us to continue coding, I have to introduce the StrategyResolver. And this is probably the most complicated piece of the source code. However, it actually makes your life easier. So it's just a matter of understanding it. The StrategyResolver is a snapshot testing utility that allows you to compare balances and view functions before and after ordinary operations. So after a deposit or before a deposit, certain balances must change. And so you wanna be able to verify that they have changed accordingly. That's how you will run proper testing. So the way this works is you're gonna have a bunch of entities that are already set up for you, and you can see the names here. There's an entity called set, which is the vault, the strategy, the one you coded, the controller, another contract, the governance, which is a wallet, and then the strategist, which is gonna be your address. And all of these entities are gonna be checked, which means that after and before each operation, a snapshot of their balances and all of their view methods is going to be stored, and that's going to allow us to run comparisons. So we're going to see examples very soon, but fundamentally you're going to have a function called getStrategyDestinations, which allows you to specify new contracts to track, and this could be either tokens or contracts that you want to track. In this case, we're tracking the lending pool and the A token. And now by customizing this function, you can actually track extra entities. The way you're going to use this is that you're going to have a bunch of functions, which we'll see as we start coding. And the functionality would be that we will receive a object called before and an object called after. This object will belong to the class snap. And we are going to have a property called balances that will receive the name of a token, in this case, want, and then the name of a contract or a destination that we specify. So I'm going to go back in the slide. You'll see that the A token destination was specified here. And now you can use it here to check what the balance of that contract in terms of want was before. And then perhaps you can run a test such as a withdrawal, and you will be able to check that the balances of want token in the A token contract has gone down. And that's because AAVE will store the tokens you deposit in the A token contract. So whenever you withdraw, you would expect that your after.balances of want for the A token contract will be less than the before.balances of want for the A token. Another function that you can use is called get, and get, given an entity, in this case set, will allow you to specify a specific view method. So you can do set.price per full share, and you're going to get the value of the view function at that time. And that will allow you to compare that, for example, after a harvest, where you would expect the value of a share to increase, then you will be able to assert that after.get of set.price per full share is higher than before.get of set.price per full share. This is absolutely one of the most complicated parts of the system. However, it makes it so that by customizing that one file, the StrategyResolver, you basically have a full test suite working for you. So hopefully, as we continue coding and we're going to code all of the tests together, this is going to make it a lot easier for you to fully understand how this works. At this point, we did write a way to run deposits, withdrawals, etc. And since it's a great time for us to test this functionality, we want to get acquainted with the StrategyResolver. So let's open that up. You already saw the explanation. So at this point, we're just gonna execute. So let's scroll to the bottom of the file. We'll see a function called getStrategyDestinations. And we even have an example here. So let's uncomment that. We do need the strategy. So all we need to do is change one of these. Let's delete the other one and then rename gauge to a token and then set it to be strategy.a token. There we go. That means that now we're going to have access to the A token entity when we run our checks on the StrategyResolver. Let's delete this extra return. Let's scroll up to the top of the file. You're going to see a bunch of functions. 3 of them are called hook, after, etc. And basically these are hooks that are going to be run after some other ordinary checks, and they're used for withdrawing, depositing, and the earn function respectively. And then we do have the confirm function for confirm harvest and confirm tend. And this means that these are the tests that you're basically exclusively writing, while the ones with hooks are already pre-written and you're basically adding only extra checks. In our case, we only wrote tending, withdrawing, and depositing. So that's what we're gonna get started with. Let's go on the hook after confirm and withdraw. You can see that we're receiving the before and the after parameters. And then we have also these params, which we're not gonna be using. We're gonna change the assert false to actually assert that the balance of want for the A token was reduced. So let's do that. Let's type after dot balances of want, and then the second parameter will be A token, which means that the want token has left some of the A token contract, because A token is a contract while want is a token. And we're gonna assert that that's less than before dot balances of want for A token. There we go. Next up, let's scroll down a little bit. Currently, we have no check for deposits, and I believe we will not extend that. So let's just change it to assert true, because there's no extra check. The quote-unquote real deposit happens during the earn function. So that's the one that we actually want to change. We're going to assert here that the balances of want for A token increases. So here on line 26, type after dot balances want A token has to be greater than before the balances of want of A token. There we go. We basically wrote our extra hook tests. So now we also want to change the tend function here. So we have the confirm tend, and this one we have to write from scratch. So let's remove the assert here. The first thing we want to verify is that the strategy is tendable. So let's assert that after the get strategy dot is tendable needs to be equal to true, because this strategy will always return true for tendable. That's the first thing. Then we want to assert that the balance of want was greater than 0. So let's assert that before dot get strategy dot balance of want, we want to say that that was greater than 0 because we had some token that we wanted to tend, basically to deposit. And then we want to assert that after the get of strategy dot balance of want has to be equal to 0. There we go. And the last thing we want to assert is that there was an increase in the balance of pool. So we can do after dot get strategy dot balance of pool greater than before dot get strategy dot balance of pool. There we go. We basically wrote all of the ordinary tests. And the beauty of this setup is that when you run your tests here, we can see the examples.strategy test harvest flow. You'll see that a bunch of functions are called snap.set something, in this case set deposit, in this case set earn, and set withdraw. And what happens, you can go on the definition by right clicking, but what happens with these is that basically what happens is the operation is run, the snapshots are taken, the stuff that we are using, and then the resolver is called, which is the strategy resolver you just wrote, which means that all of these tests will work by basically running the extra checks that you just specified, which means that all of your source code is going to be tested very thoroughly without you having to write a lot of test files. At this point, you set up the deposit and you also set up the testing that will allow to verify that deposit, withdrawals, and ordinary operations work. So the next step is to basically write the harvest function. And due to the amount of contracts that we're going to be using, this is going to be fairly complicated. And so I just want to mention that it's completely normal if you think that this is a little complex and tough to do. It just is what it is. And I want to preface that, you know, in this video, we did it in about 45 minutes, but the reality was that I spent an entire weekend working and hammering to get this out really fast. So don't get discouraged if it takes a while for you to understand the entirety of it, and just take your time. It's completely fine. At this point, we're going to go in the contracts for mystrategy.sol. We need to set it up so that we can basically figure out what the incentives that we earned. So I'm gonna go in the AAVE documentation and I'll show you the section called liquidity mining. This is a section that you're gonna have to get very familiar with, but fundamentally this contract right here is going to be the incentives controller, and as such this is the contract that we need to interact to know how many incentives we earned. As such, I'm gonna copy the address, then I'm gonna go in the contract, and after the lending pool I'll add a new variable, address public constant liquidity, or let's call it incentives controller. And we're also gonna add, we actually already have the reward token up here. So that's the token that we're gonna get from the incentives controller. Since we're dealing with a new smart contract, we also need to get the interface for it. So let's go in the AAVE documentation, click on GitHub, and you should find a staked incentives controller. You can see that it has tons of imports. We're actually going to search for the AAVE incentives controller. So copy this name, AAVE incentives controller, and then click on go to file and paste that to find the interface that we need. As you can see, we will also need to import more stuff, specifically the AAVE distribution manager. So we're gonna have to go through the same process we already did. We're gonna go in Visual Studio, open up the interfaces under AAVE. We're gonna get the name iAAVE incentives controller.sol and then create a new file. Then we're gonna get the row contract, and we need to change the version to 6.11 with the cap at the beginning. Then we need to find this AAVE distribution manager. So let's copy the name and then go in GitHub and then go to file. There we go. And this one also has another dependency, but again, we're gonna get the name, new file, then row, copy and paste, and change the pragma to 6.11. And lastly, let's figure out the distribution types. So let's copy the name, go to file, and go in the distribution types. Copy the name, create a new file of Visual Studio Code, and then get the row version and copy it and paste it and change the version to 6.11. There we go. We now need to change the imports in the AAVE incentives controller to be just /, and the same for the AAVE distribution manager to /. There we go. We can now use the iAAVE incentives controller, which we're going to be using to figure out what our balance of rewards is. So let's go in the My Strategy contract. We're going to scroll down to the harvest function, and our first goal here in the harvest will be figure out and claim our rewards. You can check the documentation for the incentives controller on AAVE, but fundamentally what we're going to do is we're going to claim everything and then figure it out. So let's do that. First of all, we need to declare a list of addresses. So address square bracket memory assets, which is going to be equal to new address. We're going to create a new address list of length 1. And this is going to have the value on its 0 slot is going to be equal to a token, because that's the token that accrues rewards on AAVE. And then we're going to call the incentives controller here. So iAAVE. And it seems like I forgot to import the interface. So let's actually scroll up and import the interface up here. You can copy this import statement right here and change it to iAAVE incentives controller. And my recommendation is just copy the name every time, because it's going to be such an easier time. Just rename it, copy it, and then paste it. There we go. We can now go back in the harvest function, and here on line 143 we're going to type iAAVE incentives controller, open parentheses, incentives controller, the constant, dot claim rewards. And you'll see that we have to claim for an asset or a list of assets. In our case, we already set it up here. The amount, we're going to just type uint 256.max, which means whatever the maximum amount we can, let's get it. And then we're going to specify that we want the rewards sent to this address. So at this point, we will receive the rewards. We need to know how many we got. So let's type it here with declaring a new variable, uint 256 rewards amount is going to be equal to IERC20 upgradable of reward dot balance of this address. Seems like I have a couple extra parentheses. There we go. This is the amount of rewards, and that means that now we will know how much we earned. And just for the sake of avoiding doing no ops, let's just do if rewards amount equals to 0, then we're just going to return 0 because we harvested nothing. So that's that, and that means that the next step is to just run the Uniswap swapping that will swap from staked AAVE, which is reward, to AAVE, which is a more liquid pair, and then through that more liquid pair we're going to swap to wBTC. So let's do that next. Let's add Uniswap v3 to our code. This is going to actually be a little complex, so again, bear with me. The first thing we need to do is find the Uniswap router. So let's search for Uniswap v3 swap router, because that's the contract we're looking for. The second result is Etherscan, so that's the address that we need. Let's get the address by copying it here. Then go in the top of the file, in the constants. I'm going to separate them because they're separated by topic, and I'll type address public constant router. That's going to be equal to the swap router. Then we'll also need the AAVE and the wETH token, because we're going to swap from staked AAVE to AAVE, and then from AAVE to wETH to wBTC. So let's find those in Etherscan. Let's search for the AAVE token and copy the address here. Address public constant AAVE token, and just by looking at it, it seems like it's not checksummed, which means that we're going to get a compilation error later. I'll show you how to address that. That's actually a good opportunity for learning. Next up, let's search for the wETH token by typing wETH in Etherscan. And again, this is a known checksummed address, so we'll deal with it. So address public constant wETH token equals to this address. There we go. So this is the easy part. Now we have to deal with the tough part of working with the Uniswap source code. So let's search for Uniswap v3 GitHub, and we'll find the only link I got is the core, but you should never use Uniswap core. It's too complex. You should always use the Uniswap periphery. In our case, we want to get the contracts. We need to get the interface for the swap router, so the iSwap router, and I believe we also need to import the Uniswap swap callback, which actually comes from Uniswap v3 core, which means that we also need to search for Uniswap v3 GitHub again, and we need to get the core code, and specifically in contracts we're gonna get the callback, which is gonna be in interfaces callback. So interfaces callback Uniswap v3 swap callback. So we need this file and we need this file. Let's port them over. We're going to start with the iswaprouter.sol, and if you check the interfaces, we already have a folder for Uniswap. So let's create a new file, iswaprouter.sol, then click on row and copy and paste, change the version to 6.11. And since we're using an older version, we also need to change the AAVE coder here. This syntax is too new. Let's go on AAVE, and because I believe we already used it with the AAVE encoder v2. This is the syntax you want to use. So change pragma AAVE coder v2 to pragma experimental AAVE encoder v2, and also change this import to just be ./iUniswap v3 swap callback. And then let's get that Uniswap v3 callback. So this is the file. Let's get the name, new file, paste it. There we go. Raw, copy, and there we go. And this should work, so we can keep this pragma solidity as it is. At this point, we have the code for Uniswap. So let's make sure to import that interface down here on line 17. Import /interfaces /uniswap /iswap router. That's all. There we go. We can now go in the harvest function, and our goal will be to swap from staked AAVE to normal AAVE. And we're gonna go here. Let's make a couple comments. Swap from STK AAVE to AAVE. And in order to do that, we need to specify some parameters. We can do that by importing the iSwap router dot exact input single params, which is a different type. It's going to be stored in memory, and we'll call that from reward to AAVE params. and this is going to be equal to a new iswap router dot exact input single params, open parentheses. We're going to put the reward, which is the input token, the AAVE token, which is the output token. Then we're going to specify the fee, which is going to be 10,000, which means that we're going to pay up to 1% in fees. We're going to send them to this address. We're going to do it now, although this is exploitable, but you know, this is an example. So now we're going to want to, the input amount is going to be rewards amount, which we got up here on line 150. And then the last two are the minimum output and the minimum output in square root. We're going to set them to 0. As you can see, this is obviously exploitable and could be sandwiched, but that said, this is good enough for now. And if you want to make it tighter, you could use something like Chainlink or an externally provided price. So let's add the semicolon. We now have our parameters. So let's call the swap function with I swap router, open parentheses router, dot exact input single, open parentheses, from the name of the variable, which is from reward to AAVE params. There we go. This is one of the swaps. At this point, we need to perform a second one. Here on line 169, we're going to perform the second one with the input params they're going to require a path. So first of all, let's declare a path with bytes memory path. This is going to be equal to ABI.encode pact of AAVE token with uint 24 with 10,000, which means that this first path from AAVE token to, we'll show it to web token, will cost us up to 1%. Then we'll do a second swap from web token, again paying up to 1%, which is 10,000, to want, which means that we're gonna get wBTC at the end of the swap. Now let's create these input parameters with I swap router dot exact input params. They're gonna be stored in memory. We're gonna call them from AAVE to wBTC params, and this is gonna be equal to I swap router dot exact input params, open parentheses. The first input will be the path. The second one will be address this, which is the recipient. Next, we're gonna execute it now, and then we're gonna want to swap for the amount of AAVE tokens we have. So we're gonna use IRC20 upgradable AAVE token dot balance of this address this. There we go. And lastly, we're gonna set the minimum out to 0, which again can be front run, so you may wanna improve that later. And now the last thing we'll do is call the swap. So I swap router dot exact input from AAVE to wBTC params. And you can see that these functions and parameters are a little, you know, a little long, and we just deal with it. So we basically wrote the function to harvest, which means that now we should definitely write a way to test that out as well. As I said before, we actually have a few others that are not checksummed, so we expect a couple of compilation bugs. Let's try getting those by typing brownie compile, and the brownie will actually tell us what we need to fix. So it seems like there was a typo. We have uint rewards amount blah blah blah. Let's see. There seems to be a typo here. We're missing a round parenthesis. There we go. Let's try again. And then you see the checksum address. You can see here that this is the mistake one, the one with the red arrows and underscore. But then you can find the one that is checksummed here. So that way you can just copy it and replace that. So we're gonna go in AAVE token and replace it with the checksum version, which basically has some uppercase variables. And then we're gonna do the same for the web token. There we go. Let's try compiling again. Seems like it's compiling. That's great. So now we're very, we're in a great spot, great shape. So the next step is for us to finalize our resolver, which means that we're gonna go in the config folder, and we're gonna finalize the harvest function for the resolver. Let's go here. Let's search for config StrategyResolver. And as you remember, we already did most of the work. All we got to do is write the harvest confirm function. So confirm harvest. If you check down here, you'll see that this stuff is commented out. And if you read through it, it will tell you that fundamentally these are the tests you're already supposed to run, because they're checking that as long as there's a performance fee that is greater than 0, then you're supposed to be gaining something. So this is a great test to run. So let's uncomment it. And fundamentally, this is all we need to do for our harvest, because it's basically saying that as long as there's a fee greater than 0, you are expecting to gain some value. And that's really important. If you want to be even more thorough, you could even check that value gain has to be greater than 0, which is probably a great idea. So you could do assert value gained greater than 0, because, or rather assert value gained equals to true. It has to be true. You have to have gained some value, because otherwise it means that the harvest was not working. So at this point, in order to test out your contract, you can simply run brownie test. This will most likely take about 10 to 15 minutes. However, this is a really good thing to run. And for the sake of time, I'm going to skip. But fundamentally, you can run brownie test with -s if you want to see all of the logs from the terminal, such as the snaps, all the checks, every time a swap happens and stuff like that. And you can also add -- interactive if you want to make it so that anytime the code breaks, anytime a test fails, you're going to be able to interact with that, try to fix it, see what went wrong, because you're going to have access to all those variables, just like with the brownie console. So I'm going to let this run, and then if there's any error, we'll address it. Otherwise, we're going to be able to end the video like that. I want you to keep in mind that if you're making a submission for Badger, that's what we're going to do. We're not going to, read the code initially. We're just going to clone the repository and run the tests. And if the tests start failing, you probably need to have a very good reason as to why they're failing, because otherwise that's not going to be acceptable. That said, let's run the test and see if something breaks. There we go. We actually see an assertion here. That's because we do have a file called test custom, which we never edited. In our case, it's actually acceptable because this is a very simple strategy. So we're just going to assert true here, and we're just going to type continue to resume testing. Unfortunately, we did get an error message, and in this case, we got an error in the swapping transaction, and you can see that we have a brownie.exceptions.virtual machine error, and we see the keyword revert, which means that something broke during a transaction, and we can see that the transaction was strategy.harvest, and we also see this error message STF, which is the message that was generated in the contract we called. If you see the highlighted line, this is exact input single from Uniswap, which means that this line reverted with the error STF when we called it. So that means that if we search for STF in the source code of Uniswap, right, I would, you would have to literally download the code. You'll actually find it that in the transfer helper, you get an exception here that says that the safe transfer from failed. And this actually gives us so much information as to what happened. And the solution for it, and the thing I forgot, is to add an approval for Uniswap to be able to use our tokens. So let's do that. Let's go in wBTC AAVE, and then go in the contract, my strategy. And then here in the initialize function, after the safe approve for AAVE, let's actually add the safe approvals for Uniswap. So we're going to do IRC20 upgradable of reward.safe approve, and we're going to approve router for type uint256.max, which means approved for as much as possible. And then we're also going to need to approve the AAVE token. So let's do IRC20 upgradable of AAVE token dot safe approve of router for the type uint256.max. So that means that now the Uniswap router can actually use the inputs that we gave it. And what you will do here is you will actually have to restart the testing suite. And I'll actually show you how to run one specific testing suite. So let's scroll up to see which test failed. In our case, the test that failed is called test are you trying? So we could search for that on the source code, and we will find that this is called, the file is also called test are you trying? And the way you will run a specific test on the Brownie console will be by typing Brownie test and then tests slash basically the path to the file, in our case test slash examples slash test underscore are you trying. There we go. If we want to have our flags, we can also add them with S and interactive. There we go. And then we can run our tests again with more confidence now. So there you have it. Massive congratulations for pulling through and writing this strategy that will earn you about 1.2% APY on mainnet. Congratulations for sticking through it. If you want to actually deploy it on mainnet, you can check the deploy script. You probably will have to just comment out a couple of lines and get that done. If you're interested in working with Badger, we actually have a bunch of openings, and we're always interested in working with more Solidity developers. So if you're interested in working with me personally or working on Badger projects, definitely reach out on the Discord. There's going to be the link in the description for this video, as well as in any of the GitHub source code. So thank you very much for watching, and have an amazing rest of your day.